Hello everyone, my name is Miranda Cook and I am an undergraduate at the University of North Carolina at Greensboro. This semester I have been working alongside Dr. Peter Delaney in the Psychology Department in the Cognition, Learning, and Memory Research Lab, where we have been furthering the academic findings associated with temporal context and the application of time tags, or memories for when. As way of introduction, contemporary memory theory assumes that temporal memory context, which is what cognitive psychologists call a memory for when you see something, is consistent across item type and individual variations. It is this context that is used to determine temporal memory judgments, or judgments about when you saw an item. It was originally proposed that we store time tags, or memory for when labels, for encountered items because it is a useful cue for retrieving information. This is important because we use time as a way to distinguish between what is new and what is old, as well as what is correct and what is incorrect. For example, if you wanted to know which of two items happened more recently, you need this temporal context. Also, without temporal context, you would have no way of recalling which items happened in which period of time. However, it was later proposed that only stimuli recognized to be old required people to make these temporal position judgments. Our previous experiments have sought to explore individual abilities in making temporal position judgments and challenge the assumption that it is consistent across item type and individual variations. In our previous studies, we have found that people are better at making temporal memory judgments for words than for faces, and for faces than for places. However, our findings have been consistent in that people perform above chance for words, and that they are very good at telling us when a word appears. However, for faces, many people perform at or below chance, suggesting that they have not had enough time to encode the facial stimuli to memory when given 5 seconds, like they were able to for words. In our current study, we proposed that perhaps people just needed more time to encode the presented items to increase accuracy. Thus, our control group was allotted 5 seconds to view each presented item, while our experimental group was allotted 8 seconds to view each potential item. However, on the basis of previous research, we do not expect to see a significant difference between groups. Specifically, we will be evaluating differences on the basis of hits, or how often individuals saw an old item and labeled it as old, false alarms, which is how often an individual saw a new item and labeled it as old, as well as zone judgment correlations, which is how accurate were the participants at determining these temporal judgments. We had a total of 68 participants who were randomly selected from the Psychology Department subject pool, and they were compensated for their time through extra class credit elicited from the SONA crediting system. Participants were asked to come into the lab and sit in front of a computer where they were asked for their consent to participate, age, and gender. They were then presented with a sequential list of 50 faces from the Bainbridge stimulus set of 10,000 faces. The control group was given 5 seconds to view each presented face, while the experimental group was given 8 seconds to view each presented face. Once they have viewed this sequential list of 50 faces, they were then tested on 55 faces. It looked a lot like this. So they were asked to sit and watch a sequence of faces. Then once they reached the test phase, they were presented with a face and asked to determine whether it was new, which means it was not in the previous sequence, or old, as in it was in the previous sequence. If they chose new, they simply moved on to the next face. However, if they chose old, they were asked to make a temporal position judgment and tell us where in the previous sequence this face fell. So this face would have been the first face, and that would have been my temporal position judgment. If allocating more time to view presented items increased accuracy, we would expect to see an increase in hits and a decrease in false alarms in the 8-second condition in comparison to the 5-second condition. This would also allow us to make the prediction that we would see a significant difference in individual zone judgment correlations, implying that more time did indeed increase accuracy. However, when you look at our results, you can see that this is not the case. When given more time to view the presented items, there were no significant differences between groups. You can also see that there was no difference in the slopes of their zone judgments in relation to the item's original position. This is the 5-second graph, in comparison to the 8-second graph. This means that allowing more time to view presented items did not increase accuracy. So what does this mean? This means that we already knew that temporal context is better for words than faces, and it is not just because people need a little bit more time to encode the stimuli. I would like to end by saying a special thank you to the Undergraduate Research and Creativity Office for their financial support, which has enabled me to spend more time with my research. I would also like to thank Dr. Peter Delaney for the time and effort he allotted to this project, as well as Kayla Kitts for helping me run the participants. As well as a special thanks to the amazing graduate students and Dr. Chang in the CLAM lab for their support and willingness to assist where they could with data collection, software programming, and data analysis. Finally, a special shout out to all my participants, because I quite literally could not have done it without any of them. I thank you all so much for your time and hope that you have a great rest of your day.